I'm gonna get all nerdy and technical in this video, but that's just so I can explain phasing, how it works, how to fix various problems, and how to achieve the best results while picking your sounds. Some of you might already understand how phase inversion works, so bear with me while I put everyone up to speed with the concept. I'm aware the following approach is quite unusual, but that's just to make sure it will help anyone understand the phasing in terms of sound. So here it goes. Imagine holding a chicken in your hands and moving it up and down. If you look at its body, well, that moves as your hands move. But if you look at its head, you'll notice it looks like it's staying in place, like it's not moving. However, in relation to its body, it moves up and down in a reversed motion. When you move its body downwards, well, its head moves upwards. Why am I saying this? Well, if you think about the body and the head of the chicken as two separate things, they behave like two oscillators running at the same frequency, but one of them being inverted or flipped or rotated by 180 degrees. So in this project, I've prepared a few examples. Over here we have an example of an inverted waveform, where this waveform is just normal waveform, but then if we add another sound on top of it, where it's basically the same waveform but inverted, we will get no sound. And yes, I'm getting all the audio here, but because each sample point on each channel goes in different directions, well, you basically have summing to zero. So like over here, when this point goes up high to, let's say, a value of 5, on the other channel this point goes to -5. So basically 5 minus 5 equals to 0. That's why we get no sound. The same way, if you add phase inversion onto the right channel as opposed to the left channel, you will get this interestingly sounding stereo effect. But the reason you should try to avoid doing this is because if you sum the left and the right channel, it's like over here I'm summing this to mono, I get no sound. Moving on, I prepared a fixed waveform which sounds like this, and then an FM which changes its pitch, making it sound like this. But then if we add these two together, we will get this result, which in this case the waveform looks like this, which isn't necessarily a bad thing if that's what you're trying to achieve, but most of the time you will end up with zones where the waveform is completely cancelled out, because over here some sample points are getting summed, but there are some areas where they get cancelled out. Like here, for example, this is another example, and all throughout the waveform. In the same way, if you add a kick onto a subby sound, you will again have some points where some bits of the sound are cancelled out. And this is why you need to use sidechain whenever you have one of these sounds, just so when your kick comes in, it sort of adds. So like you have this part plus this part. So let's discuss kicks. Like what is a kick? Well, just so we're all on the same page, I decided to basically generate a kick from scratch using operator. This is the most simplistic version, where we have this A oscillator which has a pitch envelope. And then I added 2 more voices just for a bit of body and a bit of noise and some saturation. How does it look? Well, this is the output, more or less, because some of these parameters have been changed in the meantime. But if we slow down this pitch envelope, we will get this result. So you see, this is how a kick looks if it was slowed down in terms of its pitch envelope. So it goes from a higher point and then it goes down to its root note. So like if I change this to 50, you see this is where it stops. And then we could make it so that it starts at a further point. So why did I explain all of that? Well, because I would like to show you how you could make your kicks sound from this point and getting them to sound something more like this. So what's going on over here? On my first channel, or rather the second channel, I just have this simple kick where I added some distortion from this D16 Devastator 2, and you can write down these parameter settings, but they will probably not work in your particular case because I just tweaked them to sound great with my own kick. Some of these settings might have to be changed depending on how your kick sounds. This is roughly how I made this work, and that just gives it more punch, makes it sound more full. Then on my next channel I have this kick, which is just a sample kick, and without any modulation. Right, so this is the kick. This is the sample kick. So what I did over here was I added some compression to sidechain its volume from my main kick, which is channel 2. And as I explained previously, the way a kick looks like is it has a starting point. It's transient, basically starts from, and then it goes down. So then the speed at which that transient goes down and it reaches the fundamental note, that's how you can sync these two kicks so that they sound great. And you can do that using this sampler. So over here I can choose by how many semitones I can transpose this kick. It's basically just pitching this kick up by 3 semitones with some centitone detuning. So this is like 3.50 semitones. And then this is where the magic happens, this pitch envelope, where you can sort of force this kick to have a different pitch envelope, like to make it go slower or maybe faster and so on. So for this particular kick, these are the settings that I liked the most, where its starting point, this one, so like when the kick starts, it goes by -7 semitones, and then using this decay 245 milliseconds, that's how fast the sound decays. Yeah, I guess it's a bit too technical, and it's worth trying these things out for yourself. But basically you will have to play around with the amount, with the decay, and these two, the transposition and the detuning. And then I just added a bit more saturation on top of it, and I think that's pretty much it. So let me duplicate this so you can hear the original sound and the modified sound. So this is the original sound, and to me they didn't sound great together. You see, there is something that sort of gets in the way of this kick from sounding it great. And then if you can change some of these, you might get to a point where it sounds good. Like around here, I think it sounds quite good. And then you can get even more granular with the details, and you can make it sound perfect to your taste using these things that I showed you. So like using the tune, amount, and decay. Yeah, so you will have to play around with these. Let's see, what's the other sound? Alright, so this is just a simple sub made using Corpus. It's a technique I showed you in a previous video of mine, where we take the input from this channel. Make sure it's set to post FX, not post mixer. And then I made sure to tune it to be the same as the kick. Change some of these parameters just to make it sound as I would like it. Then added a bit more saturation and drive. Then obviously some sidechaining, some sort of forced sidechaining, if you will. And then lastly, this is a simple operator sub, like some FME sound. where the note starts just in between the kicks. Like if the kick started here, this would be just in between this and another kick. So yeah, sort of like this. There's not much going on over here either. I just have two simple sine waves which have some saturation on it. Made sure the envelope, the attack, doesn't start at the beginning. I just wanted to make it a bit less punchy. So you see it sort of raises in volume gradually. As opposed to this. And then all these sounds together make up this sound. And then on top of this, I added some modular recordings of mine where I looped some of these textures. I don't really know how you could make these your own other than just playing with modular or maybe trying some crazy stuff in VCV Rack. But basically I have this sound. And then from here you end up with something like this. Then the same sound is processed differently to make this sound. And lastly, same thing. And then in the end, the entire kick group, or rather the lows, that's how I like to call it, the lows group, sounds like this. So yeah, this is why it's good to understand how phasing works, just so you can do stuff like this. Cool, that was it. Thanks for watching.